If you need to convert Modbus RTU data into SNMP for network-based monitoring systems, the UA series provides a straightforward way to do that. In this video, I'll be walking you through the UA series configuration step by step, showing exactly where to go, what to configure, and how each setting fits into the overall setup, so you can follow along and apply this to your own system. Firstly, we're going to be starting at the sign-in page. At the top of the web browser, we enter the IP address of the UA device. This IP address is how we access the device's built-in configuration interface. Next, we enter the username and password. These credentials allow us to make configuration changes on the device. Now, we click Login. Once we log in, the device loads the main configuration interface. Now, we move to the top of the page and click the Function Wizard drop-down menu. This menu is used to select the main function the UA device will perform. Each option in this list represents a different type of protocol conversion or communication role. From this list, we click Master Modbus RTU SNMP Agent. By selecting this option, we are telling the UA device to act as a Modbus RTU master, meaning it will actively pull data from Modbus RTU slave devices, and act as an SNMP agent, meaning it will expose that data to SNMP monitoring software. This selection defines the overall behavior of the device. Now, after selecting the function, a new page will appear. This page represents the configuration workspace for the Modbus RTU to SNMP conversion function. Everything configured from this point forward belongs to this specific conversion role. Now we click Save. Clicking Save stores the selected function so the UA device knows which role it should operate in. Next, we go back to the top of the page and click Module Setting. This section is where we define individual Modbus RTU devices that the UA device will communicate with. Each module we add here represents one Modbus RTU slave device. Now we click inside the module name/nickname text field. Here we type a name for the Modbus RTU device we are adding. This name is only used for identification inside the UA interface. It helps us recognize which Modbus device we are working with later. Now we click the plus button. Clicking the plus button adds a new Modbus RTU module to the list using the name we just entered. Next, we move to the right and click the Edit button for the module we just created. Clicking Edit opens the module content setting page. This page is where we define how the UA device communicates with this Modbus RTU slave and which Modbus registers will be read from it. At the top of this page, we see basic module parameters. The slave ID identifies the Modbus RTU slave on the RS-485 network. This value must match the slave ID configured on the Modbus device. The timeout, write retry, and retry interval settings control how the UA device handles communication delays and retries if a Modbus request fails. These parameters help ensure stable communication on noisy or busy serial networks. Next, we scroll down to the Modbus mapping table settings section. This is where we define exactly which Modbus registers the UA device will read and how that data should be interpreted. First, we click the Data Model drop-down menu. From the list, we select 04 input registers 3 times. This tells the UA device that we want to read input registers using Modbus function code 04. Input registers are typically used for measured values such as voltage, current, or power. Next, we click inside the data number field and change the value to 6. This tells the UA device how many registers to read starting from the defined address. Now we click the Type drop-down menu. From the list, we select 32-bit float. This tells the UA device how to interpret the raw Modbus register data. In this case, two 16-bit registers are combined into a single 32-bit floating point value, which is commonly used for analog measurements. Next, we click Add. Clicking Add creates the Modbus mapping table based on the settings we just selected. This means the UA device now knows which registers to read, how many registers to read, and how to interpret the data format. Once the process completes, the status changes to indicate success. Now we scroll down to the Modbus mapping table section. Here we click Nickname. This switches the table view so we can assign human readable names to each Modbus value. Now we scroll down to the Input Register section. We click into the first text box and type V. Next, we click into the second text box, clear it, and type I. Then we click in the third text box and type KW. Next, we click into the fourth text box and type KVAR. And finally, we click into the last text box and type KVA. These nicknames will later appear in SNMP, making the data easier to understand. Next, we click OK. Clicking OK returns us to the previous page. Now we click Save. This saves the Modbus module configuration and mapping table. Next, we go back to the top of the page and click Connection Setting. This section controls how the UA device exposes the converted data through SNMP. Here, we click the version drop-down menu and select 2C. SNMP 2C is commonly used in industrial monitoring systems and provides compatibility with most SNMP managers. Now, we move to the top of the page and click Run. This activates the SNMP service using the current configuration. Next, we scroll down and click Save to store the connection settings. Now we click Enable Converting Module at the top. This section determines which modules are actively participating in the conversion process. Here we click Edit. Clicking Edit opens a page where we can enable the modules we want to convert. Now we click inside the selection box, which selects all available modules. This tells the UA device to include all configured modules in the conversion process. Now we click OK. Next, we click Save to apply the changes. After that, we go back to the top and click Save Project. This saves the entire conversion project. Next, we click Download MIB file. The MIB file defines the SNMP object structure used to access the converted data. Now we click Download to save the file. After that, we click Run the project. This starts the Modbus RTU to SNMP conversion process. Now we move to Modbus RTU slave configure and test Modbus. On the PC desktop, we double-click the Modbus test program to open it. This program allows us to simulate or test Modbus RTU communication. Now we click Connection, then click Connect. A dialog box opens. From the drop-down menu, we select Serial Port. This tells the program to communicate using a serial interface. Next, we set the baud rate to 9600. This value must match the baud rate configured on the Modbus RTU device. Now we click OK to establish the connection. Now we double-click the first highlighted value. A dialog box opens. We change the value to 401, then click OK. We repeat this process for the remaining values, changing them to 58, 40, 22, and 45. These changes simulate real Modbus data updates. Now we place the Modbus test program in windowed mode and move it to the right side of the screen. Next, we bring the UA device web interface back into view. This allows us to see Modbus data changes and UA device updates at the same time. Now we click I/O status. This page shows live data values being read by the UA device. On the left side, we select module in slot 1. At the bottom, we move the slider to the right, which updates the value. We then change a value again in the Modbus test program to confirm the UA device updates in real time. Now we move to the MIB browser configure and test SNMP. On the desktop, we open iReasoning MIB browser. Next, we click File, then Load MIBs, and select the MIB file we downloaded earlier. The MIB loads into the browser. Now we click the plus icon to expand the MIB tree. We expand the next level to reach the Modbus RTU data objects, and we scroll down so the full list is visible. Now we select each green item and use get to request its value. Each time we click get, the return value appears in blue. These values match the Modbus RTU data we configured earlier. This confirms the full data path, Modbus RTU to UA device to SNMP. At this point, Modbus RTU data is successfully being converted and exposed through SNMP. That completes the configuration.